Today we will solve the problem 2.39 of Griffith 4th edition, Introduction to Electrodynamics. The problem 2.39 is two spherical cavity of radii A and B are hollowed out from the interior of a neutral conducting sphere of radius r as given in the diagram. So we have made hollow at two places with radius A and P. So at the center of each cavity, a point charge is placed. Call these charges as QA and QB. Now find the surface charge density sigma A, sigma B, and sigma R. See, you have a charge QA. So naturally, since this surface is neutral, this positive charge will induce the negative charge on the surface so that it will get neutralized. The surface charge is negative naturally. So you will get sigma A is equal to Q by A. Here the induced charge at the surface you have induced charges which is minus QA opposite to this QA. Minus QA divided by 4 by A square. We know that in the case of metal sphere, the electric field inside the sphere is equal to 0. By definition, this electric field is E dot TA is equal to Q enclosed epsilon naught. So the enclosed charge is 0. Epsilon naught is a constant. Since the electric field is 0, the enclosed charge is 0. That will happen only there are equal and opposite charges. So this is minus QA over 4 pi A square. And in similar manner, you have sigma P which is equal to Q by A which is equal to minus QP over 4 pi P square. Here also you have a charge QA, then here it is positive charge. It will induce us the negative charge at the surface. So both will get cancelled. So naturally this also will be minus QP over 4P square. And what about surface charge at radius here? See, here you have negative charge. So in order to neutralize it, you will have a positive charge here. This positive charge is due to QA as well as QP. So this can be written as sigma R is equal to Q by A, which is equal to QA plus QP divided by 4 pi R square. Then we will move on to section P. And now section P is what is the field outside the conductor. We know the field inside the conducting sphere is 0. Outside you have the positive charge over the surface, induced positive charges, which is equal to QA plus QP, which we have seen in section A. So the field outside the sphere is QA plus QP divided by 4 pi epsilon naught R squared along R direction, that is R cat. This is the field outside the sphere. What is the field within each cavity? See, within each cavity, the field can go from here to here. It is limited between this 0 to here. If you take this as 0 to A, so this will be up to A. So between the limit RA is equal to 0 equal to RA greater less than or equal to greater than or equal to 0 and less than or equal to A. So between this limit, this electric field is equal to qa divided by 4 pi epsilon naught r a squared r a cat. So it cannot escape from the cavity, this charge. So this is between the limit 0 to a. Same thing will happen for electric field along the at cavity P, which is equal to QP divided by 4 by epsilon naught R A RP squared RP cat. So this is also between the limit 0 to P. So this is within the cavity. What is the force act on QA and QB? You know very well the force is equal to by definition Q multiplied by the electric field. So here inside the sphere, the electric field is 0. So naturally, force is equal to 0 for both cases. Force is 0 for both cases. Then we will move on to the next section. Next interesting question is, which of these answers would change if a third charge QC were brought near the conductor? Let us say we have a charge QC, we are bringing near to conductor. What are the result will affect it? So first we will see one by one. So by bringing this charge here, definitely this surface charge will get affected. No doubt about it. That is, it will get affected the surface charge sigma r. Naturally, it will affect. Then in section A, we have seen sigma A, that is surface charge at cavity. Surely it will not affect. So this will be okay. Wow. Then next we can see sigma p, the surface charge at cavity p. Surely it will not affect due to the third charge. So this is also okay. What about sigma r at here? Naturally the surface charge will get affected. This will be the wrong. Right answer will be sigma r equal to minus qc, because if it is positive charge, it will induce us the negative charge. So qa qb minus qc divided by 4 by r square. So the in part A this will get affected, and in part B we have seen outside the electric field outside the sphere is this one. This also will get affected, because if we are introducing QC, so this will become a minus QC. This is correct and this is wrong. So that is about part B. And what about part C? Part C, we have seen the electric field due to the cavity A, EA. This will not naturally get affected, and EB also similarly will not get affected. Then what about the part T, that is force at the cavity? Surely force at the cavity will not affect by QC. QC will not get any effect other than the outer surface of the sphere. So these are the result. So it will affect only the part A, part of the part A, that is sigma R, and part P, this E outside, electric field outside this thing. So other than that, all others are the same, remains the same. Thank you very much for watching my video and supporting me continuously. Thank you very much.